Hey team, it's Tim here from Racecraft and welcome to today's members webinar where we're going to be talking all about the RaceLogic VBOX system. Now, what the RaceLogic VBOX system is essentially what certainly falls into the category of a data logger, but there's some sort of specific differences about how it works compared to some other data loggers that are already out there in the market. Now, let's start off by talking about exactly what this is. So, like most data loggers, a lot of you guys are already familiar with, essentially you've got some central logging point that's recording electronic signals, whatever they be, whether they be speeds, accelerations, driver inputs, that's recording that onto some sort of digital media. The big difference with a VBOX system is that we're also including video into the mix. Now, that's not unique to RaceLogic and the VBOX platform. There's lots of manufacturers that are already out there, already nesting video in with their systems. Probably the biggest difference about how VBOX does it is it's really integral and integrated right into the real core of the system. The whole system is really much more focused on the video aspect, and it's really, the data is almost more of a supplementary part of the logger, where most of the system is really much more focused on the video aspect, which is something that's quite particular to RaceLogic and their system, whereas most other data loggers, certainly when you get to really high-end data loggers and stuff like that, they're much more interested or much more focused on the actual log data, the squiggly lines, and the sort of the video is more of a supplementary part rather than something that's absolutely integral into how the whole system is designed to work. So if we just jump across to my laptop screen here, I just want to show you guys a couple of pictures of a system we've got in our car. Now in our racecraft GT86, we have a video VBOX Lite system. So there's a couple of different tiers to the VBOX system. Essentially, they're all a video logger based system, but there's a few different systems, obviously, and as you move up through the spectrum, you get access to more features, more usability, more usable systems as you want to stretch further and further in your capability. But the Lite system is what we've got in our car, and from what I understand, that's actually the entry-level logger that VBOX offer. It's certainly, in saying that, it's something I've used in a few different projects over the years, and I would still say it's a very, very capable system. So this is the actual logger itself. One of the beauties of the VBOX system is everything's really self-contained into relatively few pieces. As we'll go through in a little bit, it's a relatively low overhead system to use. So at its most basic level, we've got the logger itself here. Now it's a little bit hard to see, but essentially there is a slot for an SD card, which you might just be able to see the text for on the front there. And then we've got some status lights in the front to tell us a little bit about what's happening, whether it's got GPS, a current GPS lock, whether it's recording, whether it's on, what the status of the memory storage and stuff like that. And there's a little USB storage at the front here as well. Sorry, not a storage, a place where we can plug a USB cable in, which is one of the ways we can interface with it to change the programming and stuff, which is something we'll go through a little bit later. Essentially, as I said, one of the really important things to understand about this logger is it is a really low overhead logger to get started with. At the most entry level, all you really need to do is power this thing up, connect a GPS sensor to it, which comes with it, and also connect up the cameras as well. And the idea here is this particular piece of the logger is really the central brain of all of it. All you need to do is power this thing up and connect all your external sensors to it, and it'll handle the rest for you. So that's the actual logger unit itself. Then we've got a couple of other extras added onto this as well. One of them is this RaceLogic it's the time delta screen. So the idea here is that you can get some feedback on how you're going within your current lap with respect to a reference lap. So it's something we talk about a lot in our data analysis courses, always comparing yourself to a reference lap, to a time delta. A lot of you guys that are into sim racing and stuff will have already used this sort of feature where you get, say on a game on something like iRacing, where if you've got a reference lap that you're comparing yourself to, you'll get a time delta to show you whether you're above or ahead, whether you're gaining or losing time relative to the reference lap. It's exactly the same idea here. We use this to show how the driver is going relative to the reference lap, so it gives you basically a positive or a negative number depending on how you want to show that reference. So that's just another extension you can add to the VBOX system. It doesn't come by default with the VBOX Lite, but it is an added upgrade you can add, something that we use in the car. A couple of the cameras here. Now I'm actually using a different camera in this case. This one I'm actually playing with in this shot is actually Motec's V2 camera. But the point I want to make is that we've got two cameras in the system. I'm actually going to start with the primary one first. So this is one of the cameras. It's a little bullet cam here, and it's supplied with a little suction cup and everything like that, and it makes it really easy to mount to your windscreen. The idea here is this is the primary camera that's looking at the front of the car, that's giving you sort of the view of what the driver would see. And that's sort of the primary camera for the system. That one's a slightly higher definition camera. And you've got the option also with the VBOX Lite to use a secondary camera, which is what we've got here. And you can actually see that this camera is pointing back towards the driver. So this particular car is right-hand drive. This camera is on the left-hand side of the car and it's pointing back, looking at the driver. And when we go through some of the data, you'll see a little bit more about how that works as well. So this particular system we've got in our car is a 2-camera system. And as I said, that camera stuff, or using that video data, is really central to the way the whole VBOX system, the whole philosophy of how the VBOX system works. One of the details that's quite nice, or one of the things I quite like about the VBOX system, is the SD card slot, which you can just see here, which uses a full-size SD card. It actually stores the video and the data centrally all in one place on that single SD card. Now, in my experience, every other sort of, let's say, more high-end system that I've used, something like a PI or like a Pi toolbox or a Motec system, normally the log data is stored on the solid state drive of the logger itself, and then you might have an external SD card to run the other camera. Now, there are positives and negatives with that. It's not that one is better than the other, but one of the positives with having everything stored in one place on a single SD card is it just makes it a lot less overhead for whoever's doing the downloads of the data, just to grab that single SD card, transfer it to your PC, clear the memory before they put it back in the logger. It's just one less step to be able to have to manage, as opposed to having to plug into the car to download the data and then take a separate SD card out and store them in a common location on your PC or however you're viewing that. So that's one of the advantages, I would say, of the video VBOX system. Some of the other stuff that's really nice about it is, and we'll see as we move through some of the analysis, is it is a really simple system to use. There's sort of positives and negatives with that as well. While it is really simple, it means you're a little bit more limited on some of the more advanced analysis, but it does mean it's a much lower barrier to entry. And what I mean by that is one of the places you'll see the video VBOX system being used is in professional racing, where the race engineers and the engineers working on the car will generally be using a relatively high-end logger that's logging things in sort of really high detail, really high frequencies, lots of really heavily configurable sensors on the car. And what you'll often find is that in order to, I guess, streamline some of the process, particularly when you've got a pro-am situation where you've got a professional and an amateur in the car sharing the same car in endurance racing, they will often have a separate video VBOX system. The idea here is that between each session, the drivers can just grab that SD card, they can take it up to the trailer, they can just plug it into a laptop, and they can actually go through and analyze some of the differences in the way the car is being driven, as far as driving lines, as far as some of the basic data channels, and they don't really have to share any of that data with the race engineers. Now, sometimes that's an advantage if you're working in a really high-level series, because you don't actually want that really high-quality log data leaving with drivers, let's say when they leave at the end of the year or anything like that. Another advantage, but the main advantage really is that it's a lot less overhead. You don't need to be transferring these huge data files from maybe your team server to one of the driver's laptops or anything like that. It just really speeds up the process and stops the drivers getting sort of in the way of the engineers as far as having to share data, transfer data between things as well. So that's one of the reasons I find this used quite a lot in professional racing, just because it really reduces some of that barrier to the drivers getting involved with managing some of their own data analysis that they really don't need the race engineers to do for them. They can go through and analyze it for themselves. And we'll see some examples of really how easy it is to use today. One of the other advantages is this particular system uses a GPS for essentially almost everything. So it uses a GPS obviously for the speed channel, and it also uses GPS to calculate the accelerations on the car as well. So what you'll find most often, a lot of loggers, is have a system where you've got the logger, which does usually have a GPS input as well, but it's usually got either an onboard accelerometer where it's physically measuring the accelerations inside the unit, or an external accelerometer where it's doing the same thing, but it's just in an external unit. Usually you'd be placing that unit somewhere as close to the center of gravity of the car as possible to get the most true acceleration readings out of it. Now, when it comes to really digging down into that data in the finest of details, having real accelerometer data is absolutely an advantage over calculating that from the GPS speed and position channels. In saying that, if you're really dealing at more of an amateur level and there's sort of quite big differences in the data, which is typical for those of us that don't race professionally, getting that data from GPS is absolutely fine. Yes, it's not maybe quite as high resolution. In this particular system here, we're only logging everything at a constant 10 hertz. It's not really high resolution data. It's not the really sort of really high accuracy acceleration data, but still it's absolutely accurate enough to start learning some things about the way the car is being driven and finding gains in your driving, which is really what this whole system is centered about. So that's it for some of the main advantages I wanted to talk about. Oh, that's right. The other thing I wanted to say is you do also have the ability to take in external data. So as I said earlier on, this particular basic setup that we've got in our car is essentially self-contained in that it just uses GPS from its GPS sensor. It does the acceleration from the GPS. After that, the only other input really that we've got is having power going into this thing when the car is powered up. You do have the ability to take data from a CAN bus in order to feed information into this logger. So that could be logger from the factory ECU or some of the factory, the vehicle stability control unit, whether that's things like brake pressure, steering angle, individual wheel speeds, whatever it is you want, whatever you've got available on that CAN bus. If you've got available on a CAN bus, theoretically you should be able to log it with this logger. And that's certainly something that's common to most loggers out there these days, is they're more and more, they've got the ability to tap into the factory CAN bus, whether it's an aftermarket or a factory CAN bus, and get that information inside your logger. And there's no exception with the VBOX Lite. It still has the ability to do that. That's not actually how we've got set up on this car. This is set up as a standalone unit, and we'll go through some of the basic channels that we've got access to there. Now, I would say some of the disadvantages with a system like this is that if you're looking for really high quality data, high logging frequencies, really high resolution, looking at adding lots of reliability, lots of really detailed analysis, this isn't the system for you. The whole point of it is it's supposed to be really low overhead. For the majority of amateurs out there, a system like this is going to be perfect. You're not probably going to need to add on a whole lot of extras for it, but certainly in something like professional racing, this isn't going to have the sorts of features that the engineers are going to need to make decisions about the car. Certainly when you're looking at adding things like tire pressure monitoring systems, you're looking at adding damper pots, accelerometers and everything else onto the car. This system doesn't really have the ability to give you all of the powerful post-processing you need. And I find that's one of the differences with maybe a mid or high-end system versus more of an entry-level system like this. Is a lot of the value comes from having higher quality post-processing tools. And all I mean by that is essentially the software to go ahead and visualize the data in different ways, whether we're looking at time and distance plots, whether we're looking at XY plots and scatter plots, whether we're looking at histograms, fast Fourier transforms, whatever type of analysis tool you're using. If you're looking for the high-end stuff, this isn't the tool for you. But at the other end of it, it does give you the advantage of being much quicker to get going with. There's much less configuration involved with it as well. So now that's a little bit of an introduction of the system. I want to take you guys through a little bit of how the setup of it works. So we've got basically two different software tools we use for this, for a video VBOX. We've got the setup tool, which is what we use to configure everything about the way the logger works. And then we've got the analysis tool, which is what we use to look at the data that we've logged. So we're going to start off with the setup tool. So over here on my laptop screen, I've got the basic configuration tool that we use to configure our VBOX. Now I'm going to give you a little bit of a tour of how it works here. I'll actually jump across to the analysis software in a second just to give you sort of in your mind's eye so you can see how the end result looks. But essentially what we've got is a bit of a canvas here where we can build up our different displays. And I'll go through these in a little bit more detail in a second. We've got lots of different ways you can load different sort of configurations in here, which we've got all our pre-saved ones here. And we've got the main configuration option down here as well. So just before I go any further, I want to jump across and show you what this looks like, and just in terms of the video only. So if we just play that here. So what we've got here is two separate log files side by side. But essentially what I want you to take note of here is that we have a primary screen, which is the where the main camera is looking at the front window. We've got a secondary screen here, which is that other camera view, which is looking back towards the driver. Now the point of that is really to give you a little more context about what the driver's doing with the steering wheel, what they're doing with their hands, where they're looking on track, stuff like that. It's really just, again, just to add a little bit more information to the whole story. We've got a few calculations going on down here as well. We've got the lap count here. We've got the best lap of this current run. We've got what the last lap time was. We've got how far through the current lap they are. Then we've also got this GG plot here, which is essentially showing what the onboard calculation of the G-forces based on the GPS data is showing here. So we can see here when we're in a corner, pure cornering state, we've got almost pure lateral force. And then as they accelerate, it's going to transition into having some longitudinal force as well. You can see it flopping from one side to the other as we move around here. And as we brake, you can see it jump right down to the bottom there in the braking as well. The other display we've got here is a speedometer. Again, just for a reference, you can configure these in all sorts of different ways. You can have a digital speedo, you can have a physical speedo like that, and we'll see that as we go through the configuration. And the other thing we've got up here is a track map. So there's lots of different ways we can configure that track map, but the nice thing about it is it shows that little dot as we move around the track. It just shows where we are on this track. Now, this is maybe a slightly weird looking track map here. What I've got up here is it's programmed to use the generic track map. This is our local track at Highlands Motorsport Park. There's lots of different configurations they use at that track. The beauty of using this style of track is that the logger automatically identifies which configuration of the track you're using based on just driving around it. You don't need to go and, if you use the generic definition, if you've got a multiple configuration circuit, it'll automatically identify which configuration you're on. So again, it just removes one more step of having to go through and configure the logger in any more detail. So that gives you a little bit of a perspective of what the actual logger looks like in the end result. And now we'll jump back into the configuration and we'll go through a little bit more of that as well. So what I'm going to do to start with is I'm going to double click on this configuration. I'm going to open it up. It's a more generic configuration. So they give you lots of, when you buy one of these things, they give you lots of predefined templates to go through and set this stuff up for yourself. You don't need to do it from scratch. You can do it from scratch if you want, but typically the easiest way to get into it is start with one of their predefined templates and then go ahead and modify it to your own purposes rather than sort of having to have a steep learning curve of going through and sorting it all out for yourself. So what I've done here is I've loaded one of the generic ones. What we can do once we've got this new configuration loaded, we've got these buttons up the top here, so we can upload via SD card or upload via USB. That essentially means we've got a new configuration here on our PC. If I want to send it to the logger, I can either send that to the SD card, that's the same SD card that we're going to use to log everything onto, or I can plug them just with a USB cable and just send it across USB. Typically, I'm usually using a USB cable, but if you don't have one with you, it's a really nice feature to be able to just put it on the SD card as well. We've also got options up the top here to, I won't go through them now, but essentially we can preview, if you're plugged into the logger with the USB cable in real time, you can actually preview exactly what the cameras and everything see and understand what all of the different displays, where they're actually going to sit in the screen relative to things like your dashboard and your roll cage. Often it is nice to be able to see where these things are actually sitting. You don't want to be putting your displays over top of something that's going to be important, like the track or where you can see where you are on track. You want to be putting these things over things you're not really too interested in, things like the dashboard or the roll cage or anything else that's going to be in the way of your screen. So I'm not actually plugged into a logger in the car. If I was, I could show you how that works, but essentially it gives you a display of the preview of what you see live in real time. Now, as far as the elements, it's really, really super intuitive to use. So the idea here is that we've got sort of a combined speedo GG plot that I'll go through, display that I'll go through. I can just drag this thing around and put it anywhere I want. I can drag around individual components. We've also got our second camera display here. Same thing, I can drag around and put that wherever I want. We've got, by default, they've got a logo, a VBOX logo, which is just an image. And again, you can drag that around here. You can upload your own images, whether it's things like your race team or the race series that you're part of or whatever you want to have there, you can already pre-configure those as well. I just want to go through some of the basic elements we can put up here. We've got the image, which I already went through. We've got the auto track map, which is what I talked about a little bit before. The idea here is that we can drag this track map anywhere we want onto our screen, and it will use the GPS position along with the database of tracks that already exists. So this has got an enormous database of tracks from all around the world built into it. I certainly haven't had a position where I've been to a track where VBOX hasn't already had a track loaded into it. All over the world, that's been true for me. I'm sure there's some situations where there's some tracks they don't have. You have got the ability of sending the data, and they will actually make a new track for you if your track isn't in there for you. And they'll add that to the database that gets shipped with every VBOX after that. So you can also, as well as using the auto track map, you can also define a manual track map as well if you want to lock it into using one specific configuration. As I said, I prefer to use the auto track map. We've got a thing called display range here. The idea here is that you can map an image or different images to different states. So in this particular case here, the idea here is that there is a gear shift, a sort of a representation of what a gear shift is, and you can come down here for the range, and you can essentially map a different image. It's quite a little bit hard to see here, but if I hover over, you can see this image changes. You can map different inputs. So if you were taking the gear position input from something like your CAN bus or calculating it on board, then you can go ahead and map that parameter to a different image. So the idea here is that you move between gears as you move around the track, then this image would update to show the current gear. So that's just an example of how you can use something like that. What other interesting things have we got here? We've got gauges, which is something, which is what we've got shown down here. Let me just select one of these. So this is the same style that we're using in the one that I showed you before, and I'll show you a little bit of information about how they're set up. So the background is essentially just set up as what I'd call a dumb image. It's just a completely static image. You can upload your own images. You can make the gauges look like exactly what your car or whatever you want. Essentially, that background is just an image, and then over top of that, they've got some pre-configured needles that you can go ahead and map what the needle position to what you see on the image. So what we've got here, we've got some manual controls, so I can just drag this slider and you can see that's moving that needle position. So let's say for argument's sake that we've got it automatically, they've already got it set up for us. We don't need to do any configuration, but let's say for argument's sake that our 0 point was here where it says 40. I could put set minimum here, and let's say for argument's sake that our maximum position here was here where it says 280. I can say set maximum, and now our range is mapped over that range there. You can see here, I wouldn't necessarily want that because I've got the other part of the mapping is mapping the real value to what you're seeing on the display. And so we've got that from 0 to 320. If I wanted that to match what I've got at the moment, instead I would put 40 to 280 in that position instead. And that would give me an accurate mapping. So then you can go through and put in different test values and understand how it's going to look depending on how you've got that map. So the idea here is that we can go through and test different values after we've already set up our gauge. Here's where we map the parameter to it. So in this particular situation, we can see we've got access to all sorts of different data sources. So the GPS is everything that is being calculated on board with the GPS system that I talked about. So let's see what the parameters we've got access to. It's quite a few considering it's a single sensor. So we've got access, we can show how many satellites we're connected to, time, latitude, longitude, speed. Smooth speed was essentially just a time average speed to get rid of some of the noise in the signal. Heading, height, acceleration, whatever, moving time. There's all sorts of different things you can show in here, whether you want to show it with a gauge or a different display. The idea here is that we can come here and map different parameters to it. If we have access to different settings, like we've got our external display that I was talking about earlier in the lesson where we talked about the predictive lap time display. If we've got a predicted lap timing unit like we do on our car, then we've got also access to the channels that can come from that, and we can map this thing to whether it's the delta time or what the reference lap time is. There's all sorts of different ways you can do it, but we would leave that on GPS and we would leave that on speed by default. You can also come here obviously and select the units as well. So that just gives you an idea about how sort of really flexible those gauges are if we want to go through and configure them for ourselves. Let's go through a couple of more elements that we've got to set up here. Images, like we already talked about, picture-in-picture, which is simply this, the second camera display. So I think they do actually have models with more than 2 cameras. And obviously you can, as the more cameras you have, you can just keep adding them into your overlay there on the display. We've got simple shapes, which are essentially just ways to sort of group together. We can build up different groupings to help to collect together separate displays. It's really just a visual thing. It doesn't have any data meaning at all. We've got bar graphs, which again, I'll go through when I come back to our original configuration, but we can add these in here and map these to inputs. So if we wanted to, for argument's sake, if we wanted to map that to, let's say, for argument's sake, lateral acceleration. So we could come to lateral acceleration here. Now we've got the max and min values. So let's say the max value was 4 and we've got a test value, and here we put value of 2. We can see how that change updates as we go through and change the test value depending on what real value you're going to have. But the idea here is it gives you a preview to understand how that's going to look when you're actually running this thing on track. So you can change the direction, left to right, right to left. You can change the color as well just as easily. You can build these things up and use them for all sorts of different things. It's a super, super flexible type of input. So that's it for the bar graph. Let's see what else we've got to go through here. We've got text labels, which is essentially just a fixed piece of text, like a label if you want to label something. So we've got on here already pre-set up best lap time. If we were going to go add that in now down here, we have got the ability to come down here and edit that. So we can come and edit that to say whatever we want. We can also got some access to change the fonts and everything on there as well. So it's really just a fixed piece of text that's going to be used to annotate something that we've already got on there. Now the next one in line that we should talk about is the text parameter. So I'm going to add one here. The idea here, now this, as opposed to the piece of fixed text, this is a live piece of text that's going to show a real piece of data that's being logged in real time. So here we've got the ability to map that text to whatever parameter that the VBOX has access to. So in here we can map that to something to do with the, if we wanted to show speed here we could. By default it's showing satellites, we wanted to show the speed. In this case we've got this, we've got the best lap time shown here, so we can go to lap timing and select the best lap time here, and that will show on a screen for us. That will say best lap time and then show what the best lap time of that logging session is. It'll show it up for us there. Let's see if there's anything else we need to talk about here. Obviously track map, that's the fixed track map that I talked about. And the last one is XY plot. So that's what we saw with the visualization of the lateral and longitudinal G. And that's what we see displayed down here in this particular type of display. So what I'm going to do is just go through and bring up the latest one that we are using for our particular VBOX. And I'll show you how I've got that set up. So we've got down the bottom here, we've got our speed, our lateral and longitudinal acceleration. We've got some statistics about the best lap, the last lap, what lap number we're on this particular run. We've got a track map in the top there. We've got our second camera in the bottom left. Now, importantly, all of these sort of views are in a place which we'll see on the car, which aren't going to be obscuring too much of what we want to see on track. It's generally one of the things you want to be careful of, making sure you're not obscuring anything important on the main camera view, because obviously the rest of this display here is all going to be the main camera view. Up here, I've got some information about the reference lap. So I've used one of these simple shapes that I told you about before. I've got a text, sort of a fixed piece of text, and I've got the reference lap being set down here, which as you can see that's that's mapped to the reference lap parameter. I've also got time delta, which is showing us how we're going relative to the reference time that's currently loaded into the VBOX. I've got these bar graphs here, and the purpose of these is I've got those mapped also to the reference lap time. The idea here is that it's giving us a sort of a visual representation whether we're under or over, using a green bar and a red bar to showing whether we're under or over the time. So if we put in a value here, let's say we're 1 second up on the reference lap, that's, you can see we've got a green, sort of a certain amount of green up here. If we were to show that to -2, that would be a lot more under the reference lap, so that would be even better. Now, if we switched it over to a value of 0 or even a positive number, for example, it'll show nothing. But obviously, a lot of you guys will already be anticipating how we want this to work. So if then I go and put a value of 2 in here, it's going to show me a positive or a red, which is a bad thing. So that just means any positive values are going to be shown as red, and any negative values, which is when you're underneath the reference lap, are going to be shown as green. So we've also got lots of different settings, which I'm not going to go through all of the detailed setup of the VBOX here, but essentially this is about defining when, how you want the VBOX to work, how you want the log file naming to work, when you want to start and stop recording, all of that sort of stuff. This is where it's all set up here. And I've got to say, this is probably one of the easiest loggers I've ever gone through and set up. So the overhead is probably by far the lowest of anything else I've ever set up. So I do really like it for that reason. Now, the next thing I want to get into is just looking a little bit about how the analysis works. So I brought you guys to this screen before, but this is, we'll go through the analysis software in a little bit more detail. So here, if we've got up the top in the Home tab, we've got sort of these predefined views, which I can go through, which is showing the same information in lots of different ways. But really the purpose of all of these is all of these different displays are sort of set up for us. It means that they're pre-configured. And this is one of the things I was talking about as far as not having a lot of flexibility over building your own displays, but it also means that there's a lot less overhead in setting them up for yourself in the first time. So if you're only really doing basic stuff, there's nothing wrong with having these sort of pre-set up displays set up for you. But what we've got here, I've got two different outings loaded into the software at the moment. I've got an amateur versus a pro in the car. So the way we tab between those two different outings, I've got one I'm selecting in these sort of tabs up here. I've got one that's shown in this tab and one that's shown in the other. Now we can see each one of the laps listed from top to bottom and all of the runs, and we can see the lap time associated with it. In bold here, we've got the reference lap time. the fastest lap time of anything that I've got loaded in the project. And in the other tab here, we've got also the fastest lap, which is also highlighted from the amateur driver here. So we've got a 1:48.5 for the amateur, and we've got a 1:47.3, so just over a second difference between them. We can also see in the datum column here that what that means by the datum is that's the lap that we want to do all of our relative comparisons to. So normally by default, it'll select the fastest lap of anything you've got selected. You do have the ability to change the reference lap to something else if you want to. So it can use different laps as the overlays. If I want to keep going through and adding extra laps in here, all I need to do is click the show button, and what it's doing is showing me each of the videos for each of those log files, and it's also, it's a little bit more difficult to see, but we'll see in a little bit more detail later. We've got all of the log data from all 3 log files laid on top of each other in the analysis window there as well. So, but for now, I'm just going to stick to looking at 2 individual log files, 2 individual laps laying on top of each other. Down here, we've got some information, so some of the raw logged information. And what is actually happening here is if I move the cursor throughout the lap, so you can see obviously the video is updating as we go. Also, that's updating the position of the cursor on the logged data, and that is updating the live value that is shown down here in the bottom left-hand corner. So it's essentially the only ones I've got plotted here on the plot are speed, lat, and long acceleration, and my delta time. You can also plot whether it's at latitude, longitude, the number of satellites, whatever you want to use, you can add them in and out of the plot there as needed. But really the crux of the whole thing is it's allowing us to look at the data and the video all in one go here. So I'm just going to let this play, and it'll give you a bit of an idea of how that looks. So you can see down in the bottom, I've got the cursor moving through the lap. You can see the speed channel, the longitudinal acceleration, the lateral acceleration, and the delta time, which is the time difference or time loss of the slower lap relative to the faster lap. And that's something we talk about in quite a lot of detail in our data analysis courses if you guys aren't already familiar with those. But you can see here as we move throughout the lap, one of the really important things to understand about the video VBOX system is the majority of the time you'll be looking at comparing 2 things in terms of position on track. So you can plot or visualize these things in terms of lap time or in terms of position on track, and almost always you'll always be wanting to look in terms of position. That means the reason we do that is we want to look at we want to compare the same point on track, not necessarily the time into the lap. If we've got one lap that's a lot faster than the other, or any amount faster than the other, when you compare on a time basis, what you're actually doing on a distance scale, you're going to be offset from each other. And that means if you're looking at things like where people are braking, where they're getting on the throttle, when they're turning in, that means that's not going to be as useful to you as if you were looking at it in terms of a distance scale here. Now, obviously on top of looking at the data, we've also got the ability to visualize really clearly where the driver is positioning the car on track, where they're turning in, where they're doing their braking. That's really important context, particularly when you're working with, let's say, more amateur drivers. There's usually a lot of time to be found in just cleaning up some things about where they're placing the car on track, when they're doing the turn in, what they're lining the car up with as they come up to a braking point, stuff like that. So let's have a look through a couple of the different views that we tabbed through at the start here. So we've got the ability to look at purely at just at the video. Now, in some cases, this might be a nice way to look at it, where you can see things much, much clearer. You can see things in more detail if it's more important for you to be able to see exactly what's happening on track. If you're not too interested in looking at the data, that's one way we can look at it. We've also got the ability to look at, get rid of the video completely and just look at the log data, the timing data, and the raw data values down here as well. Now let's take the opportunity to dig into a little bit of that now, of how we do a basic data analysis. So typically the way I tend to use a system like this is use the delta time or the reference lap to guide me where to find the biggest gains. Now what I mean by that is if we look at the time delta difference down here, we've got our blue line, which is our fastest, our reference lap. And our red line, all our red data here is from the slower driver. So what we're looking for is places on track where one driver is losing time with respect to the other. So essentially that's just looking at how long it takes to cover a certain amount of distance, and it's plotting that time variance. So we've got, anytime you've got a slope up like this, that means we're losing time. So this is an area where we want to look at where one driver is losing time with respect to the other. We've also got this big slope here where one driver is losing quite a lot of time to the other. So let's dig into what exactly is going on there now. So looking at the speed trace is a really good way to start looking at why you've got a performance difference. We can see straight away what's really obvious. Because we're looking at here in terms of a position plot rather than time, we can see across the x-axis here, we've got position shown. We've got the blue driver simply going quite a lot deeper on the brakes. They're going a lot longer. They're sort of slowing down at a somewhat similar rate. but they are going sort of further along the track when they're doing their braking. That's really clear to see just from the speed trace alone. Now, if we look at the longitudinal plot, we see something, we see a little bit more information about how that driver is actually doing that. So we can see here that in the red data, let me zoom in a little bit here. Sorry. Just frozen up on me a little bit here. Here we go. So we can see the red driver, which is braking earlier. We can see the longitudinal force is dropping down earlier. And we can also see that they're dropping to a larger minimum as well. What I mean by that, they're sort of accelerating down too much, or maybe too aggressively. They're holding too much brake pressure at that point on track relative to the Pro. The other thing that we see here is we've got quite big variations in the longitudinal acceleration for the amateur in the red line here. Now what's happening here, because this particular car doesn't have a sequential gearbox, they're having to heel toe as they go down through the gears. And what that ends up doing is sort of the worse your technique is at that, the more variation you get on the brake pedal. So what you're doing, you're still using your right foot to do all of the braking force, but you're sort of blipping the throttle as you go down through each of the gears, and inevitably that leads to sort of some difference on the amount of pressure you're using on the brake pedal. And that's what we see here in these quite large variations in the longitudinal acceleration, which are definitely a bad thing for performance. Anytime you've got the pitch of the car changing in a braking zone like that, you're sort of changing the amount of weight transfer you've got moving back and forward on the car. You're unsettling the car. It's not, usually you want that brake force to be as sort of smooth and consistent as possible. And while it's not perfect for the Pro, certainly the variations are a lot lower in that particular point on track. So really, that's one big point that we should get across there, is that's where one of those big differences is coming from. The other one was up here. Let's have a look at a similar thing up this section of track. We can see in the speed trace, we have the blue driver, the Pro driver, carrying a lot more speed through this section of track here. So this is a position on track where the drivers have the ability to, well, have the option of slowing down a lot more like the amateur is, or carrying a lot more speed through here. And really, a lot of the story is again told by the longitudinal acceleration plot. We can see here the blue driver is braking later. We can see that the red driver is not only are they braking earlier, they're also braking a lot harder and scrubbing a lot more speed off. And that's again another typical thing you'll see with amateur drivers, just overslowing the car on entry. And as a result, it usually means, which is exactly what we can see here, they end up getting on the throttle harder at exit. The problem is they've overslowed the car on entry. They realize that they know that they've done it, but because the car's going so much slower, they also, not only do they know they need to get back on the accelerator, they're able to because the car is going so much slower. So you've got a lot more lateral force component available in the tires. So that's exactly what we see here in this section of the longitudinal acceleration plot. As you can see, the red driver is getting back up to positive longitudinal acceleration. It's quite a lot sooner than the Pro, but that's, initially you might look at that and say, hey, look, this driver's getting on the throttle earlier and harder. That's better technique. If you look up at the speed trace here, we can see why they're able to do that. There's a huge difference in the speed trace here. Now, if I put my cursor at this particular point on track and I look at the difference, I can come down here to the bottom left and I can see the Pro is doing roughly 155 and the AM is doing roughly 134. So that's roughly 20 Ks difference to that section of track, which is a massive difference in speed, certainly, and where a lot of that time loss is coming from. Let's go through a couple more of the different displays we've got set up. So we've got another one which is just adding essentially something similar to what we saw before, but we've added in the video, and we've also added in a track map here. So you can see as I move throughout the lap, we can see these little cursors down here moving throughout the lap and just showing us, giving us a little bit more context about where we are on the track. You can also see we've got some information showing us a little bit about driving lines. You've got to take this a little bit with a little bit of a grain of salt, because it does come down to the GPS accuracy you've got at the particular track you're running at. But you can see here where the driving lines are within sort of, it looks to be relatively useful as far as how the track limits are laid out there. But again, I would be careful with reading into the driving lines too much with GPS in general. We've got the ability just to look at terms of data and video. We also have the ability to, if I just get this right, I can drag this up and sort of change and customize the position of each one of these displays. So you do have a little bit of flexibility. We've got the ability just to look in terms of graph. If you want to dig into the actual data itself in terms of the squiggly lines, you can do that just here. We can bring up the session data, which I'll come back to this in a second because I want to talk about how the sectors work. But essentially it's giving us a breakdown of the lap times and then sector by sector for each lap. And in this particular case, we've got what this time delta here is relative to the best lap, whether it was better or worse. In this particular case here, we've got the driver doing a better sector 1 on this lap than the fastest lap shown as a negative and in purple, as opposed to all the rest of them here, which are shown as a plus and red, which means that they were slower than that sector on the reference lap. We can look just in terms of the track map, or we've got this last one here, which is putting all of the possible views together in one place. So as I said, one of the things I wanted to talk about here was the definition of the sectors. So by default, I've got the default sectors set up here. I've let it choose the sectors for itself. I'm not actually sure how that algorithm works, how it goes through and defines those sectors, but you do have the ability to customize this for yourself. One of the things you really have to be careful of when it comes to defining sectors is putting them in the right place to get usable information. You don't typically want to put your sectors in the middle of a braking zone or in the middle of a corner. It leads to a lot more variability and be able to compare one sector to the other. Typically, you want to be putting your sectors, start and finish of each sector, in the middle of a acceleration point where you're going to be just purely accelerating in a straight line. That makes it much more useful for actually looking at the different performance and different sections of the track, well, in my experience anyway. Certainly for the average track length, you don't want to be going sort of more than 3 or 4 sectors. Certainly in most cases, 3 sectors is my starting point when I'm starting to use sectors. This is a really useful technique for, obviously you don't always do your best sector on your best lap. Sometimes you do your best sector 1 on the first lap, and you might do your best sector 3 and maybe the 3rd or 4th lap, whatever it is. But having the ability to break things down to sectors, which is exactly what we show in this case here, where we've got a faster sector 1. It means I might want to go back and look at that lap and just look at that sector 1 section of track and understand what I was doing different at that section of track. But before I want to go any further, I just wanted to say, if you guys have any questions that have come up today, whether it's about data logging, in particular the VBOX, or anything else, race engineering, car setup, whatever it is, anything that we do here at Racecraft, you're welcome to chuck those in the chat, and Sammy will put those through to me, and I'll get onto those soon. The last thing I want to talk about is how we actually go through and define the sectors in the video VBOX. So if I come up here to File, there's this little tool called the Start Finish Wizard. We've got some information here. It's giving us some prompts about exactly how this works. But essentially, it's actually interesting here. This is showing these blue lines are plotting all of the data from that particular log file, and you can actually see where the pit lane is here as well. You can see you can see where the pit lane, where you exit off into the pit lane and then you get back onto the track. That's what that little sort of excursion off the side of the track there is. So the start finish line is shown with this green dot, and all our splits that we're breaking up to here, that we see by default they've set up 6 splits for us. Each one of those is indicated by a blue dot. Now you'll see here these are really not lining up where I want them to be, or most of them anyway. We've got middle of a corner, we've still got some lateral force on here. We've certainly got some lateral force on here. That's not going to give me the results I want as far as breaking up my sectors. This one in the middle of the straight's fine, but what I'm going to do is start fresh and just go and remove all of these. So I think it says here, use Shift and Control and right button. So I'm going to hold Shift, Control, and right click on each of these. I'm just going to go through and remove each of these that I don't want, and we're going to go through and redefine our own. Now we just use right click to put them in a place where we do want. So I know, so you can look at this from the data to find out where a place on track where you know you're accelerating. It does pay to go and look at the data to make sure you know you're putting them in the right place. I'm really familiar with this track, so I know exactly where I need to put them. I want to put them in the middle of this short straight section here. The track then continues around and actually goes underneath the track, and this point comes back around this hairpin, and then we've got another long straight here. So at these 2 points here, obviously I want 3 sectors. That means I need to put 2 dots in here to break this up into 3 individual sectors. That means we've got 1 sector running from the start finish to this, we've got the 2nd sector running all through this section of the track, and the 3rd sector is running from this dot to the start finish line. So I've got the option to just use this temporarily or save in the track file. I'm just going to use this as temporary for a start, but you can see now the whole software has updated, and we now break those down into 3 individual sectors there, which is, from my perspective, a much more useful way to use the sectors rather than use these sort of arbitrary sectors that start in the middle of corners and braking zones and stuff like that. I find it's definitely better to start with less and sort of add complexity as you go, rather than sort of swamp yourself with a whole lot of information. It just really slows down your process. You can also see the track map there has updated to, let's bring it up in large view. We can see the main track map has also updated to those new sector definitions as well. So guys, that was a bit of really quite a brief run through of the whole video VBOX system. Hopefully you guys can see sort of the positives and minuses with something like this. Certainly there's lots of people out there using loggers that are much, much more sophisticated than this. And there's a time and a place for those. But in my experience, when you're working as an amateur and just doing this sort of on the weekend, it's not your main job, I often find less is more as far as having something that's easy to set up, easier to maintain. The data management is easier. I think there's a lot to be said for something like the video VBOX. Certainly when you add the camera aspect involved with it as well, being able to see exactly how the car's positioned on track, which is a place where you often find a lot of gains. So guys, I'm just going to jump across to the chat now, and I'll see if we've got any questions that have come through as the base of the webinar. Okay, I've got one question here. Suhas Govindaraj. Suhas is asking, I've heard that VBOX has one of the accurate GPS system, and also some high-end systems in VBOX have the ability to measure roll angle, pitch angle, and even slip angle. If you know how they calculate pitch, roll, and slip angle using just by GPS, please brief out. What would the rough cost of one of those systems be? Yeah, so I'm not necessarily familiar with the exact higher end VBOX system that you're talking about. Obviously, like I said at the start, this particular VBOX that I'm talking about here is the light version. It's sort of their more entry-level version. I know that they've got more high-end versions. What I would say, it would be essentially impossible to measure things like pitch, roll, and yaw angle with a GPS. Certainly, I can't think of a way that you'd be able to do it accurately. To some extent, you can certainly get higher in GPS as far as running at higher frequency, but maybe I'm wrong, but I really can't think of a way that you'd be able to use GPS to get that sort of high resolution data. The way I would say that they're probably doing that with some sort of inertial measurement unit, which is sort of another way of saying an accelerometer mixed with a set of gyros. So you've got a 3-axis gyro and a 3-axis accelerometer, and you would simply be able to have that as an input to the VBOX. You would even be able to do that with the VBOX Lite system, really. You'd only be logging it at 10 hertz, but you would have the ability to be able to connect an external accelerometer if you wanted to. So I would say the way that they would be doing roll and pitch would be based on inertial measurement unit. You can use some basic math to go back and differentiate the signals to be able to get to be able to calculate the roll and pitch angles. I would say as a general rule that while that data is useful, it absolutely is useful in its own right, you generally want to be correlating that with other sensors you've got in your car, whether that's damper position or anything else that you use in your car, accelerometers, whatever other systems you've got in your car. But absolutely, that is a valid way of doing it. The slip angle, I see you've got a question there about slip angle, which for anyone who's not sure what slip angle is, essentially each corner of the car has an individual slip angle. The idea here is that for a given path, the tire, let's say we're turning left and this is the front right tire, the tire will actually be turned into the corner more than the direction it's heading. What I mean by that, if the instantaneous velocity of the car is going in this direction, let's say we're going around a skid pad in a circle like this, to exaggerate it a little bit, the tire will actually be turned in more to the corner. So essentially what we look at each corner of the car, we look at the angle difference between the instantaneous velocity of that corner of the car and the angle that the wheel is actually pointing in, and that defines a slip angle. Now really, to properly define slip angle, what you really need is a slip angle sensor, which is usually an optical sensor. You have got the ability to do it with, to estimate chassis slip angle with an inertial measurement unit as well. I would say if they say that they are measuring slip angle, they'll be doing it with an inertial measurement unit. In my experience, nothing really beats an optical slip angle sensor. There are positives and negatives to both. Inertial measurement unit, of course, there's a big range of high quality to sort of more entry level ones there. You really need something really high end to be able to properly estimate slip angle or chassis slip angle, and from the chassis slip angle, you can then go and calculate out your individual tire slip angles. I have used those before in some benchmark chassis testing. My personal opinion is that I prefer to use an optical slip angle sensor. One of the downsides of an optical slip angle sensor is they are really expensive. They're a bit of a pain to maintain. They can be, there's only really relatively small windows in which they can work with. And I'll just sketch out exactly what that looks like just to make that clear, because it's probably not a very good explanation. Essentially, if that's your road surface there, you've got this little sensor, which usually looks something like this. Got some wires running off to the logger, and essentially what it's doing is projecting a light beam down here and using some post-processing information to look at the two components of velocity. So if we're looking from the top, and this is from side view, if we're looking from top, what we're essentially doing is we've got a sensor, and if we've got a fully longitudinal component, the car's driving in a straight line. As soon as you start cornering, and this thing's mounted to the sprung mass, to the chassis, you're going to have some angle, and it's essentially taking the longitudinal, let me control it properly, it's taking the longitudinal and the lateral components, and it's using some math to work out the angle that the chassis is traveling at when it's doing that. So a couple of different ways. It depends how they're doing it. I would say they're probably doing it with an IMU and an inertial measurement unit. Your last question there was about cost. I don't remember exactly. I think the VBOX Lite is maybe possibly in the range of say maybe $1,000 US, somewhere like that. I'm sure you can contact VBOX to get a more definite price off them. I would say overall it's actually a really good deal. Like you get 2 cameras with that, you get the main logging unit, you get a GPS antenna to go with that, all of the software. It's a lot of hardware and software for the money, and certainly I think there's a lot to be gained with using a system like this. Okay. We have got another question here from Sue asked, how much weight reduction in a car will affect lap times? Is corner weight balance more important than reducing weight? Okay, so as to first part of that question, how much will weight reduction reduce a lap time? That's how long is a piece of string. That's really impossible to say without all the different definitions of the car, how heavy this thing is, what tires you're using, what track you're running on, what track configuration you're running on, what sort of surface you're running on. The best way, well, there's multiple ways you can do this. In my experience, the way I've usually worked out something like weight sensitivity to lap time is using some sort of lap simulation model. Now, there are all sorts of ranges of lap simulation. There's really, really simple stuff that's really relatively quick and easy to get into, and there's incredibly high-end stuff that's both expensive and time-consuming to use. Usually somewhere in the middle is usually where you start getting really accurate results, or really useful results at least. I mean, as far as orders of magnitude, you might be looking, let's say you might be looking in the terms of maybe per 10 kgs, maybe 0.02, 0.05 of a second on the average lap, something like that. Maybe up to 0.1 on something that's really a lot of vertical load sensitivity on the tires. It's a really hard thing to answer depending on obviously the average track length, the car configuration, stuff like that. So it's not something I can probably get too specific on without knowing a few more details and really running the simulation for myself. But it's absolutely looking at that trade-off between weight reduction and lap time is absolutely something that you'll be looking at, particularly when you're trying to understand whether it's actually worth spending money on upgrading something. How much lap time am I going to get based on how much money am I going to have to outlay to do this upgrade to make something lighter on the car? And the last part of that question is corner weight balance more important than reducing weight? That's probably a pretty tough thing to say. I mean, if your corner weight balance is really bad, yeah, it probably is going to be more important than reducing weight to a point. And saying that if your corner weight balance is pretty close, then reducing weight is going to be more important as well. It really depends how bad one is compared to the other. I would say overall, correcting your corner weight balance is certainly usually a lot easier than reducing weight. Reducing weight out of the car usually means redesigning components. It means building them out of more expensive, more exotic materials. It means buying more expensive gear for your car, as opposed to just properly corner balancing or corner weighting your car. That's something that's really accessible to a lot more people. That is actually something we offer a course on, a practical corner weighting course, if you're interested in looking into that more as well. So I would say getting the corner weight balance, getting the corner weighting done and getting it balanced properly is more of a given. That's not something you really should be compromising on it at all. So I think it's maybe a little bit of a strange comparison because I think it's really a given that you should do corner weights. You should be putting emphasis on no matter what. And after that, reducing weight, reducing center of gravity height and stuff like that are things that you should also be looking at. Okay, guys, that's all the questions I've got so far for this webinar, but thank you very much for attending. I hope you got something out of it. Now, if you guys aren't watching live, remember, you can, if you're watching this in archive, you can go into the forum and ask a question there in the webinar section. I'll be happy to jump on that and give you a little bit more depth on any questions you've got. Remember, guys, we've got lots of stuff coming out on the socials, YouTube, Facebook, Instagram, lots of really tech-heavy content. If you're interested in more, make sure you're checking us out. Thanks, guys. I'll see you next time.
That was just a taste of what we put on every week for our HPA Gold members. Our Gold members are able to watch these live and ask questions and get answers while we're presenting. After the webinars have been hosted live, they're added into our webinar archive where our Gold members can re-watch them at their leisure. We've currently got over 240 hours of existing webinar content covering topics on engine building, engine tuning and wiring. This is one of the fastest ways to expand your knowledge on a wide range of topics, as well as to stay up to date with the latest tools, trends and techniques in the performance industry. Our Gold members also get access to our private members-only forum, which is the best place to get fast answers to your specific questions. Gold membership can be purchased for just $19 per month. However, you'll also receive 3 months of free access with the purchase of any of our courses. Click the link in the description to learn more.